Hey guys, welcome back to another RASK maths tutorial, and in this tutorial I'm going to be showing you guys how we can prove the derivative of tan x. So a lot of people know that the derivative of tan x is secant x squared, or secant squared x, or 1 over cos squared x. But I'm going to show you guys how we can prove it, and it's actually really simple. So what we need to do is first we use the identity tan x equals sin x over cos x, and obviously the reason for this is because these are all defined in terms of ratios of sides on a right angle triangle. So we know sin x is equal to the opposite over the hypotenuse, cos x is equal to the adjacent over hypotenuse, and we know tan x is defined as, well, let me just write x as that angle, is defined as the opposite over the adjacent. So from this, you should be able to see that if we put sin x over cos x, we're going to get opposite over hypotenuse over adjacent over hypotenuse. Now, the over hypotenuse is just going to cancel out if we can multiply top and bottom by the hypotenuse. And so that's equal to the opposite over the adjacent, which is equal to tan x. So that's basically why that's true. Let me just put this out. Okay, so now that we have this identity, tan x equals sin x over cos x, what we can do is we can now differentiate tan x by differentiating sin x over cos x. And to differentiate a fraction, we can use the quotient rule. So I'm just going to state the quotient rule. It is v du minus u dv over v squared. And let me just define u and v. So in this case, u would be sin x and v equals cos x. So we can obviously work out what du is. We know that the derivative of sine is cos x, and the derivative of cos x is minus sin x. So putting all of this into the formula, sorry, not the formula, the expression we have here, the derivative of tan x is equal to v du, so that's going to be cos x multiplied by sin x minus u dv. So this is going to be sin x multiplied by minus sin x. And hang on, must have made a mistake here somewhere. Ah, yes, v's not. Yeah, du is cos x, not sin x. Okay, so small mistake, but now it's all over v squared, so that's all over cos squared x. Now, I think you guys can see what's going to happen here, but we can write this top bit as cos squared x plus sin squared x over cos squared x. And, well, you might be able to see there's two ways of writing this. So we could either split fractions up and get 1 plus tan squared x. As you can see, we split it like that. Or we could just say that's 1 over cos x using the identity sin squared x plus cos squared x equals 1. And that is equal to secant squared x. So yeah, that is how we prove the tan x derivative, just the proof of that. Now you might be asking, how does this happen? Well, again, this is just a statement of Pythagoras. So if we remember the definitions, in a right angle triangle where x is the acute angle, sin x is going to be opposite side of that over the hypotenuse. Cos x of that is going to be the adjacent side over the hypotenuse. So if we do sin squared plus cos squared x, that's equivalent to opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. And remember, these are inside a right angle triangle, so we're allowed to use Pythagoras' theorem, which means if this is our angle x and this is the opposite and adjacent, we have the relationship opposite squared plus adjacent squared is equal to hypotenuse squared. This is just a squared plus b squared equals c squared. So as you can see, this top side is just going to become hypotenuse squared over hypotenuse squared, and that's equal to 1. So that's why that identity is true. So overall, that is how we prove this derivative. Thanks for watching, and I'll see you guys in future tutorial. Bye.